Maya Zhang stood out among the gathered students at the Centauri Engineering Academy, and not just because she was the only human. While her alien classmates' bodies shimmered with bioluminescence or gleamed with cybernetic enhancements, Maya wore a simple gray jumpsuit with a worn toolkit strapped to her belt. The orange sunlight of Proxima cast long shadows across the Academy's crystalline testing grounds as Instructor Vexthor materialized before the assembled group. The instructor's quantum form stabilized, revealing a being composed of swirling dark matter contained within an environmental suit. "Today's challenge," Vexthor announced, their voice resonating directly in the students' minds, "will test your ability to survive in extreme conditions. You must construct a shelter capable of withstanding a Category 7 plasma storm." Murmurs rippled through the gathered students. The Nexian twins, with their silicon-based bodies, exchanged knowing glances through their compound eyes. Krax, the towering mantis-like Arcturian, clicked his mandibles in anticipation. Even the usually stoic Zen-12, an artificial consciousness housed in a hovering maintenance drone, emitted concerned peeps. "You have exactly one planetary rotation to complete your structures," Vexthor continued. "The storm will test them to their absolute limits. Survival is not guaranteed." Maya felt the weight of stares from her classmates. She knew what they were thinking. Humans were considered primitive by most galactic standards. Their technology was centuries behind the average spacefaring civilization. But Maya had something her peers often overlooked: generations of human experience dealing with natural disasters. "Begin," Vexthor commanded, and the testing grounds erupted into activity. The Nexian twins immediately began extruding crystal lattices from their bodies, weaving them into complex geometric patterns that would theoretically deflect the plasma storm's energy. Krax deployed swarms of self-replicating nanobots that started constructing a massive dome of living metal. Zen-12 projected advanced force field calculations into the air, their drone body already assembling quantum stabilizers. Maya walked to the edge of the testing grounds, studying the terrain. She pulled out a simple soil testing kit, analog, not digital, and began taking samples. The other students occasionally glanced her way, their expressions ranging from pity to disdain. "Fascinating approach, Student Zhang." Vexthor materialized beside her, "though perhaps not the most efficient use of your limited time." "With respect, Instructor," Maya replied, carefully examining the soil's composition. "I believe understanding the foundation is crucial to any structure's survival." "An admirably philosophical perspective," Vexthor responded, their dark matter forms swirling with what might have been amusement. "Though philosophy may offer little protection against plasma winds." Maya didn't respond, instead pulling out her toolkit and beginning to dig. Her movements were precise, measured, each shovelful of dirt placed with purpose. While her classmates' structures grew increasingly elaborate, the Nexian twins' crystal palace now stretched nearly 30 meters high, and Krax's nanobots had constructed a fortress that pulsed with artificial life. Maya's work remained deceptively simple. Hours passed. The twin suns of Proxima Centauri began their slow descent toward the horizon, casting the testing grounds in deep crimson. The first signs of the approaching storm appeared, ionized particles dancing in the air, creating haunting auroras overhead. Maya's shelter took shape, a partially subterranean structure with overlapping layers of locally sourced materials, each layer serving a specific purpose. She had incorporated principles of architecture that humans had developed over thousands of years of surviving earthquakes, hurricanes, and tornadoes. "Quite primitive," Krax commented as he passed by, his nanobots putting the finishing touches on his fortress's quantum-reinforced walls. "Though I suppose it's impressive for a species that only recently mastered fusion power." Maya smiled politely but kept working. She had learned long ago that actions spoke louder than words, especially in the face of doubt. Her shelter might not gleam with advanced technology, but it incorporated something equally valuable: millennia of hard-won human experience. As the storm approached, casting the sky in sheets of plasma-charged lightning, Vex Thor called the students together for final inspections. The instructor's dark matter form crackled with energy as they examined each structure. "Impressive work, all of you," Vex Thor announced. "Though as always, theory must bow to practical application. Take your positions. The storm begins in precisely 10 minutes. Maya returned to her shelter, running her hands over the reinforced supports one last time. Above her, the sky had turned into a roiling mass of plasma and energy. In the distance, she could see her classmates' structures glowing with power, force fields humming, crystal matrices singing, nanobots swarming to strengthen weak points. Her own shelter remained silent, steadfast, ready to face whatever came. As the first waves of plasma lightning struck the testing grounds, Maya smiled to herself. Sometimes the simplest solutions were the most elegant, a lesson humanity had learned through centuries of facing nature's fury. The true test was about to begin. Innovation under pressure. The first wave of the plasma storm hit like a luminescent tsunami. Sheets of energy cascaded across the testing grounds, painting everything in otherworldly hues of purple and green. Maya watched through a carefully designed viewing port as her classmates' structures activated their defenses. The Nexian twins' crystal palace refracted the plasma energy, splitting it into harmless spectrums that scattered across the ground. Carax's nanobot fortress pulsed with adaptive algorithms, its walls constantly reconfiguring to disperse the storm's force. Zin-12's quantum-stabilized bubble shimmered as it repelled wave after wave of plasma discharge. Maya's shelter, in contrast, remained dark and silent. She had positioned it partially underground, using the planet's natural magnetic field as part of her defense strategy. The overlapping layers of treated soil and locally sourced minerals acted as natural insulators against the plasma's electrical charge. Preliminary readings are fascinating. Vex Thor's voice echoed in their minds as the instructor observed from their monitoring station. Though some approaches appear more dynamic than others, the subtle dig wasn't lost on Maya, but she remained focused on monitoring her shelter's integrity. She had learned during her years on Earth that natural disasters didn't care about flashy technology. They tested the fundamental principles of physics and engineering. As the storm intensified, the first signs of strain began to show. The Nexian twins' crystal matrix started emitting high-pitched frequencies as the plasma's energy overwhelmed its diffraction capacity. Hairline fractures appeared in the previously perfect geometric patterns. Compensating, one twin transmitted to the other, their silicon-based bodies vibrating with effort as they attempted to regenerate the damaged sections. But each new wave of plasma energy came faster than the last, giving them less time to adapt. Carax's fortress faced different challenges. The nanobots, sophisticated as they were, struggled to maintain cohesion under the intense electromagnetic interference from the storm. Sections of the living metal walls began to lose their organization, creating vulnerable gaps in the structure's defense. Impossible. Carax chittered, his mandibles clicking rapidly as he directed swarms of backup nanobots to the weakening areas. These units are rated for quantum fluctuations far more severe than this. Zin-12's approach initially seemed the most stable, their quantum calculations accounting for every variable of the storm. But as the plasma intensity increased, even their advanced force fields began to flicker. The drone's processors whirred audibly as they attempted to compensate for the unexpected power drain. Maya's shelter, meanwhile, continued its passive resistance. The carefully arranged layers of materials worked in concert, each performing its designated function. The outer layer absorbed and dispersed the plasma's kinetic energy, while the inner layers provided progressive protection against heat and electrical discharge. She had incorporated a principle learned from studying historical Japanese pagodas, flexible support structures that could bend without breaking. When particularly strong plasma waves hit, her shelter would shift slightly, dissipating the force instead of trying to oppose it directly. Most intriguing, Vex Thor commented, materializing briefly near Maya's viewing port. You've chosen to work with the storm rather than against it. Nature usually wins head-on confrontations, Maya replied, making minor adjustments to her shelter's ventilation system. Humans learned that lesson the hard way over many generations. The instructor's dark matter form swirled thoughtfully before disappearing again, returning to their observation post as the storm entered its next phase. The sky above the testing grounds had transformed into a churning maelstrom of plasma energy, with arcs of lightning that seemed to defy physics itself. A particularly massive plasma bolt struck the Nexian twins' crystal palace. The structure's luminescent defenses flared brilliantly for a moment before several key support nodes shattered. The twins worked frantically to reroute power and maintain structural integrity, but the damage was spreading faster than they could repair it. Warning: Zin-12 broadcast to all students, their usually steady electronic voice carrying traces of concern. Storm intensity exceeding predicted parameters. Quantum stabilization failing. Maya watched as her classmates' advanced technological solutions began to falter one by one. The storm was proving more powerful than any of their sophisticated systems had anticipated. But her shelter's design didn't rely on prediction algorithms or power supplies that could fail. It was built on principles that had weathered Earth's worst natural disasters: hurricanes, earthquakes, solar flares. As another wave of plasma energy washed over the testing grounds, Maya felt her shelter shudder, but hold firm. The temperature inside remained stable, protected by layers of insulation designed using principles developed by ancient desert cultures on Earth. The structure's partial underground placement helped anchor it against the storm's increasingly violent forces. Sometimes, Maya muttered to herself, remembering her grandmother's words, "The best technology is the one that can't break down." The storm's fury continued to build, and Maya knew they hadn't yet seen its full strength. But as she watched her classmates struggle with failing systems and depleted power supplies, she felt a quiet confidence in her shelter's resilience. The true test was still to come, and the night would prove long indeed. Breaking point. The plasma storm reached its zenith as the third hour began. The sky had become a writhing mass of energy, more akin to a living entity than a natural phenomenon. Lightning bolts of impossible colors, some in spectrums human eyes had never evolved to see, lashed across the testing grounds with increasing frequency. Maya's environmental suit registered the external temperature at over 3,000 degrees Celsius. Through her viewport, she watched as the Nexian twins' once magnificent crystal palace began to lose its battle against the elements. The fractures in their defensive matrix had spread like spider webs across the entire structure, each new plasma strike widening the gaps. Primary lattice failing. One of the twins broadcast in panic. Secondary systems non-responsive. Their warning came moments before a massive plasma bolt struck their shelter directly. The crystal structure, despite its advanced design, couldn't handle the raw power. It shattered in a spectacular display of light and energy, forcing the silicon-based twins to abandon their creation and seek emergency shelter in one of Vexthor's safety bubbles. Carax's nanobot fortress was the next to show critical signs of failure. The electromagnetic interference had grown so intense that his swarms of microscopic robots could no longer maintain proper communication. Sections of the living metal walls began to lose cohesion, flowing like mercury before solidifying in twisted, useless shapes. Impossible. Carax's typically confident voice carried traces of fear. These are ninth-generation quantum-linked nanites. They shouldn't be susceptible to mere electromagnetic disruption. Maya observed silently as the Arcturian's technological marvel literally melted around him. The storm had evolved beyond anything their advanced systems had been programmed to handle. Carax managed to escape just before his fortress collapsed entirely, his mantis-like form barely visible through the plasma-charged air as he made his way to safety. Zin-12's quantum-stabilized bubble held out longer than the others, but even their sophisticated calculations couldn't account for the storm's increasingly chaotic behavior. The drone's processors were working at maximum capacity, trying to adapt their force fields to the changing conditions. Alert! Power reserves at critical levels, Zin-12 announced, their electronic voice crackling with interference. Quantum stabilization failing. Shield collapse imminent in 3, 2, 1. The force field flickered and died, leaving the artificial consciousness exposed to the storm's fury. Zin-12's drone body barely managed to reach one of the emergency shelters before being completely overwhelmed by the plasma energy. Through it all, Maya's shelter remained standing. Its outer layer had begun to glow with absorbed heat, and the structure groaned under the intense pressure, but the core design held firm. She continued making minor adjustments to the ventilation system, carefully managing the internal temperature and pressure. Fascinating. Vexthor's voice resonated in her mind as the instructor's dark matter form partially materialized inside her shelter. Your classmate's advanced technology has failed, yet this seemingly primitive structure endures. How? Maya wiped sweat from her forehead before responding. Humans learned long ago that the most advanced solution isn't always the best one. We spent thousands of years studying how natural structures withstand extreme conditions. This shelter incorporates principles from termite mounds, deep-sea hydrothermal vent communities, and ancient Earth architecture. A particularly violent plasma surge rocked the entire testing ground. Maya's shelter shifted with the force, its flexible support structure bending but not breaking, just as she had designed it to do. The reinforced layers continued their work, each performing its specific function in protecting against the storm's different aspects. The others tried to fight the storm. Maya continued, checking her instruments. Their shelters were designed to repel or neutralize the plasma energy. But sometimes, the best way to survive isn't to fight against nature. It's to work with it. Vexthor's form swirled thoughtfully, an unexpectedly sophisticated philosophy from a species often considered technologically primitive. We had to be sophisticated, Maya replied, making another minor adjustment to the ventilation system. When you don't have advanced technology to rely on, you learn to understand the fundamental principles at work. Every natural disaster on Earth taught us something new about survival. The storm outside reached new levels of intensity. Plasma arcs danced across the ground like living things, seeking any weakness they could exploit. The remaining structures on the testing ground, storage units, monitoring equipment, even some of the emergency shelters, began to show signs of stress. Maya's shelter shuddered but held firm. The outer layer had begun to develop a glassy sheen where the plasma energy had partially melted the treated soil, but this too was part of her design. The melted material would actually provide additional insulation, another lesson learned from studying the effects of lightning strikes on desert sand. Your species continues to surprise us, Vexthor observed. Perhaps there is more to learn from Earth's history than we previously believed. Maya managed a small smile, even as another plasma wave rattled her shelter's foundations. The universe is full of surprises, instructor. Sometimes the oldest solutions are the best ones. We just have to remember them. As the storm continued its relentless assault, Maya's shelter stood as a testament to human ingenuity and the accumulated wisdom of generations. While her classmates' advanced technology had crumbled in the face of raw natural power, her design, based on simple but profound principles, continued to protect her from the chaos outside. As the plasma storm began its gradual descent from its peak intensity, the testing grounds had become almost unrecognizable. The once pristine crystalline surface was now scarred with plasma burns and littered with the remains of shattered technological marvels. Through it all, Maya's shelter continued its vigilant stand against the elements. Inside the main observation chamber, where the other students had taken emergency refuge, the atmosphere was thick with disbelief. The Nexian twins huddled together, their silicon-based forms still vibrating from the residual energy exposure. Krax paced nervously, his mantis-like frame casting long shadows as he contemplated the failure of his nanobots. Zin-12's drone body emitted occasional sparks as their systems struggled to process what had occurred. Statistical improbability exceeds standard parameters, Zin-12 announced, their electronic voice still distorted from storm damage. Human engineering should not have survived when quantum-stabilized technology failed. Maya's voice came through the communication system, calm and steady. It's not about the technology. It's about understanding the fundamental forces at work. Through the observation window, they could see her shelter standing firm. Its outer layer had developed an almost artistic pattern, where the plasma energy had transformed the treated soil into something resembling volcanic glass. The structure moved subtly with each aftershock, demonstrating the flexible resilience that had kept it intact. Would you care to explain your methodology, Student Zhang? Vexthor materialized in the center of the chamber, their dark matter form more stable now that the storm's interference had decreased. Maya activated her shelter's external camera feeds, displaying them on the observation room's screens. The design incorporates several key principles we learned on Earth. The foundation is based on ancient Japanese pagodas, which can withstand earthquakes because they distribute force through multiple flexible joints. She highlighted different layers of her shelter's construction. The outer layer was inspired by how lightning transforms sand into glass. I knew the plasma would partially melt the treated soil, creating an additional protective barrier. The ventilation system mimics how termite mounds maintain stable internal temperatures despite extreme external conditions. The Nexian twins moved closer to the displays, their compound eyes analyzing the design with newfound interest. But there are no power sources, one of them noted. No energy fields, no computational systems. That's exactly the point, Maya explained. Every additional system is another potential point of failure. Earth's history taught us that the most resilient structures are often the simplest ones, as long as they're built on sound principles. Krax clicked his mandibles thoughtfully. Our civilizations have become so reliant on advanced technology that we've forgotten the basic laws of physics still apply. My nanobots were programmed to adapt to millions of scenarios, but they couldn't handle the raw power of nature. Humans never had the luxury of relying solely on advanced technology. Maya continued, running a diagnostic check on her shelter's integrity. Every hurricane, earthquake, and tsunami forced us to understand how natural forces work. We learned to build with nature's principles rather than trying to overcome them with brute force. Zen 12's processors whirred as they analyzed the data. Your shelter's design contains no redundant elements. Each component serves multiple purposes, creating a system that is both efficient and robust. This is elegance we had not anticipated from human engineering. Vexthor's form swirled with what appeared to be approval. Perhaps this is why the Galactic Council has begun showing more interest in Earth's architectural heritage. Your species' solutions to survival challenges offer a perspective we had not considered. Maya emerged from her shelter, her environmental suit slightly singed but intact. The testing grounds around her still crackled with residual plasma energy, creating an otherworldly backdrop to her approach to the observation chamber. On Earth, we have a saying, she said as she entered. Necessity is the mother of invention. When you don't have advanced technology to rely on, you're forced to truly understand the problems you're trying to solve. The other students gathered around her, their earlier disdain replaced by genuine curiosity. Even Krax, who had been the most dismissive of human capabilities, seemed eager to learn more. Could you teach us about these Earth principles? The Arcturian asked, his pride giving way to honest interest. Perhaps there are applications we haven't considered. Maya smiled, remembering all the times human history had been dismissed as primitive by her alien classmates. Of course. But first, you need to understand that technology isn't always the answer. Sometimes, the most advanced solution is the one that's been refined by thousands of years of trial and error. As the storm's final remnants dissipated overhead, the gathered students began an animated discussion about combining Earth's time-tested principles with their own advanced technologies. Maya's success had opened their eyes to a different kind of innovation, one that didn't rely on computational power or quantum physics, but on a deep understanding of natural laws and the wisdom to work with them, rather than against them. 1 week after the Plasma Storm Challenge, the Centauri Engineering Academy's Grand Lecture Hall was filled to capacity. Students from all departments had gathered to witness something unprecedented. a human teaching advanced engineering principles to one of the galaxy's most prestigious institutions. Maya stood at the center of the presentation space, surrounded by holographic displays showing various Earth structures that had withstood centuries of natural disasters. Behind her, a real-time reconstruction of her shelter's performance during the plasma storm played on loop, drawing murmurs of appreciation from the assembled crowd. "The Great Pyramid of Giza," Maya explained, enlarging the image of the ancient structure. Built over 4,000 years ago, yet it survived earthquakes, wars, and extreme temperature variations, not because of force fields or quantum stabilizers, but because its designers understood fundamental principles of physics and engineering. The Nexian twins, their crystal matrices fully repaired, raised their appendages. But surely such primitive construction methods have no place in modern galactic engineering. Maya smiled, having anticipated this question. "Let me show you something interesting." She overlaid the pyramid's internal structure with a diagram of a modern planetary shield generator. "Notice anything familiar?" Gasps of recognition rippled through the audience. The basic geometric principles used in the pyramid's construction were remarkably similar to those employed in the most advanced planetary defense systems. "Great minds think alike," Maya continued, "even when separated by millennia. The difference is, the pyramid builders had to understand these principles intimately because they couldn't rely on computers to do the calculations for them." Karax, who had become one of Maya's most enthusiastic supporters since the challenge, clicked his mandibles in agreement. "I've begun incorporating Earth-inspired passive cooling systems into my nanobot architectures. The efficiency improvements are significant." Zen 12 hovered near the front row, their drone body now upgraded with several nature-inspired modifications. Query: could human architectural principles be applied to quantum computing systems? "That's exactly the kind of thinking we need," Maya responded, bringing up new diagrams. "The pattern of blood vessels in a human brain, for example, shares remarkable similarities with efficient quantum data routing systems. Nature had billions of years to perfect these designs. We just need to learn from them." Instructor Vexthor materialized beside Maya, their dark matter form somehow more substantial than before. "The Galactic Council has reviewed the data from our recent challenge. They have approved a new department at the Academy, Earth Historical Engineering and Natural Systems Integration." The announcement caused excited chatter throughout the hall. Maya felt a surge of pride, not just for herself, but for all of humanity. Their primitive solutions were finally being recognized for their true value. Furthermore, Vexthor continued, "Student Zhang has been appointed as the department's first instructor, with a mandate to bridge the gap between Earth's historical knowledge and modern galactic technology." The audience erupted in applause, led enthusiastically by Maya's former competitors from the Shelter Challenge. The same students who had once dismissed human engineering as primitive were now eager to learn its secrets. After the presentation, Maya found herself surrounded by students from dozens of different species, all asking questions about Earth's architectural history. The Nexian twins wanted to know about Gothic cathedral support structures. Karax was fascinated by termite mound ventilation systems. Even Zen 12 had begun researching ancient Roman concrete formulations. "You've started quite a revolution," Vexthor observed as the crowd finally began to disperse. Though perhaps revelation would be more accurate. Maya watched as groups of students continued their animated discussions about combining Earth principles with their own technologies. "We humans have a saying, everything old is new again. Sometimes the best way forward is to look back and understand what worked in the past." Indeed, Vexthor agreed. "Your species has given us a valuable reminder. In our race to advance technology, we had forgotten that innovation doesn't always mean complexity. Sometimes the most elegant solutions are the ones that have been refined by time and necessity." As Maya gathered her materials, she noticed a message on her datapad. The Galactic Council had approved her proposal for an interstellar archaeological expedition to study ancient structures across Earth's various civilizations. Teams of alien engineers would work alongside human archaeologists to uncover forgotten engineering principles that could revolutionize modern space construction. "You know," Maya said to Vexthor as they left the lecture hall, "humans have another saying, standing on the shoulders of giants. We thought we were learning from advanced alien civilizations, but it turns out we had some giants of our own all along." The instructor's dark matter form sparkled with amusement. Perhaps that is the greatest lesson of all. True advancement doesn't come from dismissing the past, but from understanding it deeply enough to build upon it. As they walked through the Academy's crystalline corridors, Maya could see the impact of her success already taking shape. Students were studying Earth history alongside quantum mechanics. Engineering projects incorporated both advanced technology and time-tested natural principles. The barrier between primitive and advanced was beginning to dissolve, replaced by a more nuanced understanding of innovation. The end.